Hey guys, so today we're going to talk about a couple of different um, important pieces of trigonometry and angle measures that are important for us to know going forward into our trig unit. So we're going to talk about something called radians. These were introduced at a small level in your geometry class, but we're going to talk about them a little bit deeper here for us. So we're going to start with degrees. We're a lot more comfortable with degrees. We've been seeing degrees probably since you first learned about angles, and that's what we see most. So radians and degrees come from this idea of a circle. And so we know that in a circle, we have 360 degrees. And so degrees are one way we can measure an angle, right? So I can measure an angle based on the knowledge that there are 360 degrees in a circle. Well, just like you could measure a distance in feet or inches, or there's a lot of different ways to measure distances in different units. There are also other ways that we can measure angles. So this unit would be degrees. We can also use what are called radians. And in one circle, there are 2 pi radians. So what this knowledge allows us to do is it actually allows us to convert between degrees and radians. So we might be more comfortable, and often you will, if you need to measure an angle, you'll use degrees, but then when you do calculations with that angle, you would probably want it to be in radians just because it's a little more commonly used that way. So a couple of things before we move into that converting. One of the things when it comes to an angle, any angle you have, so let's say that this was a 30-degree angle here, it is possible for an angle to be positive, negative, and it is possible for an angle to be bigger than 360 degrees or 2 pi radians. Think about if you watch any sports where people, I'm a big fan of the Olympics, right? And so if I'm thinking about the specifically the Winter Olympics, there are multiple situations like the half pipe, where part of what the snowboarders will do is do multiple rotations, and they don't just call it 360 degrees if they do 2 full rotations, right? They actually then, in that case, if they do 2 full rotations, they've done 360 and 360 again, would have a 720 degree rotation, right? So if we go more than 360 degrees, so if we were to take this and come around twice, we would do 300, that would be a 360 plus 30 degrees. So that would be a 390 degree angle. So it is possible to go bigger than 360 degrees. On the other side, in terms of negative, it's also possible for your angle to come this way. And in this case, since it's coming down instead of going up, this would be a negative angle. So this, in this case, if I knew this was 30 degrees, right, this negative angle would be 360 minus that 30. This would be a negative 330 degree angle. So we want to also think about the fact that we can have negative angles. So if we come back to this idea of our radians and our degrees, what this knowledge allows us to do, right? 360 degrees is equal to 2 pi radians. That's just like we know that 1 foot is equal to 12 inches. That allows us to convert between feet and inches. 360 degrees is equal to 2 pi radians. But because of that 2 pi, what helps us is actually being able to take out that 2. So if we divide both sides by the 2, we now have 180 degrees being equal to pi radians. And this is what's going to be incredibly important for you to remember and to know when it comes to being able to convert between radians and degrees, because we can use 180 degrees equal to pi radians to be able to convert from degrees to radians or vice versa. So let's actually start by converting degrees to radians, and we're going to use our dimensional analysis to do this. That's what I find, especially when you're starting these, is the most accurate way to make sure you're doing this correctly. So if we start with an example, let's start with a simple and really common one, 90 degrees. And we want to convert 90 degrees into radians. Well, if we think about our dimensional analysis, the important things is that we know we're going to use pi radians in 180 degrees, and we want that 180 or the degrees to cancel out, right? And so in order to cancel something out, we need to have it on top and bottom. So in this case, I know since I've got the degrees on top, I'm going to put 180 degrees on the bottom, allowing me to then cancel, because I can only cancel top to bottom. I can't cancel across. I can only cancel top to bottom, because remember, anything divided by itself is equal to 1. Something times itself is not equal to 1. It's equal to something squared, right? So the only way to cancel is to have something divided by itself. It's the same idea with units. So since I have degrees divided by degrees, those degrees will cancel. And here I would have pi radians on top. So that allows me to cancel my degrees. And then what I would do, if I continue this, is I would have 90 over 180 pi radians. And in radian form, we keep pi as pi. We want an exact answer. So if we used a decimal for pi instead of keeping the pi in that symbol, we'd no longer have an exact answer. So 90 divided by 180 would give me 1/2. So this would simplify down to being pi over 2 radians, or 1/2 pi radians. If we look at a second one, let's do another one a little less common, from degrees to radians. And let's use a negative this time, just for the sake of it, right? Just to make sure we still see it's going to be the same. So negative 495 degrees. Yes, it's bigger than 360. Yes, it's negative, but that's okay. It just means it was multiple rotations in the negative direction. I'm still going to work with this the same way with my dimensional analysis. I still want to cancel those the degrees, and in order to do that, I have to have something on top and bottom. So I still have my 180 degrees on the bottom and my pi radians on the top. That cancels out my degrees, and then I would do negative 495 divided by 180 as a fraction. So I could put that in my calculator if I wasn't sure, and find that as a fraction, and that is negative 11 fourths. And then we usually just put the pi on top in the numerator. So negative 11 pi over 4 radians. What about the other way? What about going from radians to degrees? So we're still going to use the same identity here, the same equality, that 180 degrees is equal to pi radians. So let's start with 2 pi over 9 radians. And again, here I'm going to use my my same idea with my dimensional analysis, where I've got my radians on top, right? So this I know is radians. So I need my radians on the bottom, and that's where I'm going to have my pi. That allows my radians to cancel, and I'd have my 180 degrees on top. Notice here as well that my pi will cancel because I've got pi on the top and pi on the bottom. So what I'll have is 2 times 180 divided by 9. So I have 2 times 180 divided by 9 degrees, which if I simplified that out, gives me 40 degrees. So 2 pi over 9 radians is equal to 40 degrees. We could also do this with a negative or something bigger than 360. So let's do 23 pi over 6 radians, and we want to turn that to degrees. So again, I've got radians on top here. I need radians on the bottom. That's where my pi comes in. And so then I'd have 180 degrees on top. So my radians cancel. Again, my pi's cancel. That will happen almost every time. Very rarely do you have radians without the pi. It would be a very odd situation to have that. It is possible, but it's rare, okay? So now I would have this as 23 times 180 divided by 6, which when simplified would give me 690 degrees. So 23 pi over 6 radians is equal to 690 degrees. So what this allows us to do is to, again, convert between radians and degrees depending on which format is going to be more useful for us in the moment. This also is a way for you to practice your dimensional analysis, and this is also going to be some important information for you going into the rest of our trigonometry lessons for this unit.